Hello, and welcome to the video companion to AWS S3 Bucket Malware Scanning, an AWS and Trend Micro modernization workshop. In this walkthrough, we will cover implementing serverless architecture to detect malware in objects that are uploaded to Amazon S3 buckets, and how to build integrations off of that scanning process to meet your own application workflows. This video companion is designed to be used alongside the written material, which is available at the link in the description below, or can be found under the S3 Bucket Malware Scanning header at this URL on screen. Feel free to check out some of the other AWS and Trend Micro workshops there as well. You can use the embedded chapters and timestamps to jump to specific parts of the workshop, and we'll also be providing material reference points and other info for your consideration over the course of this video companion. So, hopefully that covers all the housekeeping. Let's get building. Let's start by covering the two prerequisite accounts you'll need to perform today's workshop material. The first of these is of course going to be an AWS account, which you hopefully already have or can sign up for without much guidance. But secondly is going to be the Trend Micro CloudWatch security platform, and there are two ways to obtain a free trial to the platform. The first is going to be directly through the AWS Marketplace, which we can do by going to the Marketplace and then searching for Trend Micro CloudWatch as a subscription. If you do not have access to managing Marketplace subscriptions, you can also obtain a 30-day trial directly through the CloudWatch portal by heading to cloud1.trendmicro.com/trial. You will have to provide a business email, as we will be sending a confirmation link for the account, but as you can see here, you will get a free 30-day trial, which will allow you to use both file storage security as well as all of the other services in the CloudWatch platform. Once you have confirmed access to both AWS and CloudWatch, we are going to have to start by provisioning an S3 bucket that we want to protect with file storage security. We can do that by going into the AWS console, accessing the service S3, and creating a new bucket. When we provision our bucket, we have to be cognizant of the fact that our name must be unique to the global namespace. So I will go ahead and name my bucket something I assume won't be taken. All other parts of the policy can remain default, and I will create the bucket here. So here's my brand new bucket. Now we can go ahead and deploy Trend Micro CloudWatch to this bucket and begin testing. Now that we have our bucket provisioned and hopefully access to the Trend Micro CloudWatch platform, we can begin deployment to our S3 bucket and then test our implementation. Over in CloudWatch, we will head to File Storage Security. Making sure we're in AWS, we'll click Deploy, and then deploy the all-in-one combination scanner and storage stack. Let's make sure that we deploy in our intended region. Again, for consolidation purposes, that will be US East 1 for me. We'll click Launch Stack, and in this same browser window, we're going to head over to CloudFormation. Let me give this a unique stack name. And then for the purposes of the workshop, we're only going to fill out one parameter, the intended bucket to scan. So from S3, we can grab our bucket name, and I'll paste that right here. And then you can always read about the other parameters in the template at the documentation for file storage security. But in this case, I can scroll all the way down and make sure that I acknowledge, of course, the potential for IAM resource creation, and then create the stack. This all-in-one workshop will take a variable amount of time, usually between 5 to 10 minutes, to initially provision for our initial bucket. And during this time, let me quickly explain what we'll be implementing with file storage security. Our all-in-one stack is going to provision as two parts. The storage stack, which will listen for new files being uploaded to our target S3 bucket, and then sending those files to the scanner stack for the security scan. After the scanner stack executes the scan and then publishes the results to the SNS scan result topic, our storage stack will listen for those results and do a couple of things. Tag the object with some object tags we can review later, and then push those scan results to any customized post-scan action that we may have set up listening for the results off of the scan result topic, SNS. Using the power of movie magic, our all-in-one stack has finished deploying in record time, but we have a couple of more things to do before we can begin testing our file storage security implementation. Headed over to outputs, we will need to provide a couple of parameters back to the Cloud One platform to finish the connection to the backend. So we are going to need the scanner stack management role ARN. Let's go ahead and copy and paste. And then the storage stack management role ARN. Copy and paste. Then we can hit submit. And hey presto, using a bit more movie magic, we can finish the back-end connection between the Cloud One console and our S3 bucket. So let's begin testing. In order to generate our first detection in file storage security, we're going to perform all of the steps required within the AWS console itself. For starters, we'll go ahead and open Cloud Shell in the top right here. I have it open in another tab. And then we're going to run a series of commands available in the workshop material. The first of these commands is going to download the iCar test file, which we know to be the most dangerous malware file known to man, wink wink. So we can confirm that we have now downloaded the iCar test file to our environment. And the second command is going to copy this iCar test file from AWS Cloud Shell to our target S3 bucket. So again, grabbing the command from the workshop, we are going to change one field in the command here, substituting name of bucket goes here for the name of our bucket. And then, of course, hit enter. We will then see the successful upload of the iCar test file to our S3 bucket at the given name, in this case, icar.txt. After successfully uploading the file, we can go into our S3 bucket, find the uploaded object, and then scroll down and review the resultant scan tags. We can see that we have a malicious scan result on our iCar test file, which is of course a file designed to generate malware detections and is benign otherwise, as well as confirmation tags that the scan has successfully occurred at the given date and time. We can confirm this finding within the Cloud One console as well. Going from the stack management page to scan activity, we can see the single file uploaded this hour with the malware type virus and confirmation that we have uploaded it to our intended target S3 bucket. Let's recall that after file storage security successfully scans an object, it publishes those scan results to the topic scan result topic. As a result of this, we can then create custom workflows built off of those scan results, and we'll cover a few over the course of this workshop. But before we do that, let's highlight how this information is made available in a service like Amazon CloudWatch. Going back to CloudFormation, we are going to move from the all-in-one CloudFormation stack to the scanner stack and pick up the value of the log group for our scanner lambda. Then, taking this group name, we will head over to CloudWatch, and in the log groups section, paste the value we grabbed from CloudFormation and find our log group. Inside the log group, we can go to the only log stream we have. This corresponds to our testing upload, where we uploaded the icar test file. And if we head to the top of the log events screen and typed in scanner result and opening the scanner result line, we can see all of the information that was used to inform the tags we saw on the S3 bucket console a little bit earlier. We have, of course, the file name and the intended bucket. And we, of course, have some of the information that we saw in the Cloud1 console as well, those being the malware name and, of course, the upload object type, in this case, virus. If we want to, we can also review scan results in Logs Insights inside of AWS CloudWatch. So if we, again, make sure we have our scanner lambda log group name copied, we can paste it into Logs Insights, select it, and then run the following query on this log group. Again, because we don't have too many files uploaded to the S3 bucket, we generate the single query result, and then of course can expand this to confirm in slightly neater formatting what we saw in the raw log stream inside the log group. But now that we can verify the Cloud1 file storage security logs and have access to them in CloudWatch, we can begin creating automations based on this CloudWatch data. When it comes to provisioning custom post-scan actions, the most popular of these is the promotion quarantine setup we can have off of our initial scanning bucket. As a prerequisite, we are going to create 2 more buckets in the S3 console here. One for receiving quarantined files we deem to be malicious. I will go ahead and name that one -Q. And then a promotion bucket for receiving files that file storage security deems to be non-malicious. In this case, I will denote that with -P on the bucket. Once we have our buckets provisioned, we can then supply this information as well as some parameters from our CloudFormation template to the serverless application we have in the AWS serverless app repository. Here in the serverless app, there are some fields we are going to fill out in application settings. The first of those, of course, being the initial upload bucket for file storage security. So I will grab this from the console and paste that. Then we have our bucket name for promotion. This is, of course, our -P bucket. And then in quarantine, our -Q bucket. For the purposes of this example, I will be leaving the default action for our objects here, in this case being move. If your use case would prefer that you have a copy of the file copied from the initial scanning bucket to our promotion and quarantine environments so as to not disrupt file availability, you can change that in the application settings. Lastly, we are going to head back to CloudFormation and grab the scan result topic ARN, available in our storage stack. Let's make sure we have no trailing or leading white spaces. And then, acknowledging that this app can create custom IAM roles, we can click Deploy. Again, with a little sprinkle of movie magic, mine has already finished creating. So we can begin testing our promotion quarantine setup. Going back to Cloud Shell, we have one object here, of course, our icar test file from earlier. In addition, I'm going to download one additional, hopefully clean file that we can use to test the promotion aspect of our post-scan action. So in this case, I will download just the index metadata for Google. And we have two objects now, our iCar test file and the Google homepage index HTML. If we go back to the reference material, we can of course grab the commands that will allow us to upload these objects to our intake S3 bucket. So first we will upload our malicious file. Let me grab our bucket name, paste that, and call it iCar2. And make sure we have our file name changed appropriately. And then we are going to upload our google.com index file and give it a different name. And now that we've uploaded both of those objects, let's head back to S3 and see what file storage security has done to those files. Back in S3, if we go into our initial intake bucket, we will see one object still remaining. This is, of course, the initial iCar test file that we used to test file storage security. If we briefly click back to Cloud Shell, recall that the names of our uploads are iCar-2 and index, neither of which are in our target S3 bucket. So clicking back out, if we head to our quarantine bucket first, we see our iCar2 upload, again with all of the scan tags that match the one on the initial iCar upload. And then going to our promotion bucket, we will see our upload of the google.com index file. And scrolling down, the same tags have been applied with different values. Of course, in this case, this being a non-malicious file or a non-detection generating file, like the iCar test file, we have a different set of scan result tags. If you can infer from the new layout and new window on the screen, for this integration, we are going to be provisioning a Slack webhook that we will then use to communicate the scan detections from file storage security to a Slack channel of our choice. You can see in my environment, I've provisioned the channel FSS-Slack, and we'll start by adding an integration for an incoming webhook. This will open the window, and we can add this to our channel. So selecting FSS-Slack, we can scroll down, and I'll change one parameter here just to customize the username for the integration bot, and save settings. We're going to stay on this screen because we will have to provide the webhook URL to a serverless app we can grab from the reference material. So if you follow along in the reference material, you will see a link to open this application, which will then take us to the serverless app repo once again. Over here in application settings, we will need a few parameters that we can take from CloudFormation and from our webhook screen. So we need the scan result topic ARN. Again, this is going to be located in the storage stack information in CloudFormation. We will need our Slack channel. This is, of course, FSS-Slack. Our Slack webhook URL. We'll use the copy URL button. Make sure we have no leading or trailing spaces. And then our Slack username, which we've of course customized to be fss-slack-bot. Then, acknowledging the IAM roles, once again we will click Deploy. Now that our deployment of the Slack integration has finished, we can generate a detection using the same methodology we've used in the earlier examples. So I will head back to Cloud Shell, and using the same copy methodology, we can paste the object, and I will call it icar-3 this time to maintain originality, and upload that to our target bucket. We can see here, instead of going to our S3 environment, we have generated the detection. Thank you, FSS Slackbot, you've been very helpful. And we get some of the information that would reflect the findings we saw in the log stream in the log group in CloudWatch. From this Slack integration, you can create your own integrations based off of the File Storage Security API to forward these results to whatever program you may have in mind. This example is, of course, for Slack. For our final integration, we are going to discuss the use case where we may have ephemeral buckets as part of an application. As these buckets are provisioned, utilized for a brief invocation period, and then no longer required, similarly, we can automate our deployment of file storage security around the creation of new S3 buckets, perform the scanning we need to do, and then deprovision that scanning architecture once the S3 bucket is no longer required and subsequently deleted by any kind of existing application workflow. Starting in our Cloud One environment, we are going to go to the administration screen and create a new API key for the purposes of this integration. We'll call this FSS, Lifecycle, give it full access, and then provision it in the language and time zone of our choice. I'll leave these as default. And then I'm going to take this key value, because it won't be available later, and paste it into our notepad. Afterwards, in the reference material, I'm going to click the Launch Stack button that will then take us to a CloudFormation screen where we can supply our Cloud One API key and some other parameters. So we will start with the API key, our Cloud One region endpoint. Again, you can grab this information by going to your account settings and confirming the region of your account. We will need the scanner stack SQS URL available in CloudFormation. So again, I'm in my scanner stack, and I will need the scanner queue URL. And lastly, our scanner stack's name, again available in CloudFormation. Clicking Next, and Next one more time. As we are always wont to do, let's confirm that CloudFormation might create IAM resources, and then Submit. Once our Lifecycle CloudFormation template has finished deploying, we can test the integration by deploying a new S3 bucket and ensuring that it gets picked up by the event. So we'll call this one. That should be original enough. And if we click Create, we'll see the new bucket here. And if we refresh our CloudFormation stacks, we see the brand new storage stack for this bucket being provisioned here. So I'll give this a little bit of time. Once it finishes completing, we can test the opposite lifecycle event by deleting the bucket. Hey there, past Mark. Thanks for being patient. So now that we have the creation of our lifecycle storage stack complete, let's go back into S3, pick our same bucket, begin the delete. So we'll copy and paste. And now that the bucket has been deleted from the environment, we'll go back into CloudFormation and see the delete in progress kicking off. So we can wait for that to finish, and now we have a better understanding of when an integration like this would be useful in the case of ephemeral buckets being provisioned by an application. After you've finished the workshop material, in order to clean everything up, there are only 2 tasks you have to perform. First is going to be the deletion of the header or root stack here, which will also delete the subsequent nested stacks that were created as part of the file storage security deployment. Once you've confirmed the deletion of the all-in-one main stack, we can simply go into our CloudOne console and delete the listing on the file storage security stack management screen. This will remove the listing from the CloudOne console and ensure you have a nice clean environment for future use. And that's everything. Congrats on completing this modernization workshop. Hopefully you now have a better understanding of when you can use a solution like Trend Micro CloudOne File Storage Security to perform object scanning on your S3 buckets, so that way as part of any further application workflow or for compliance reasons, we are validating the state of objects being uploaded, that they don't contain any kind of malicious information or ransomware. If you're interested in following along with some of the other modernization workshops we have, you can check them out at trendmicro.com/AWS workshops, and that URL should be in the lower third right about now. With that being said, also be on the lookout for when we offer these modernization workshops as part of an in-person immersion day, if you find that you learn better in a classroom setting. These immersion days are offered both virtually and in person, in conjunction with architects from AWS. So that way you learn from both parties a better understanding of security from both the AWS native and third-party sides. With that being said, I want to thank you for your time, and hopefully this modernization workshop was of some value. Until next time, we look forward to working with you again soon. Have a great day.